difficult to deal with compared with kinetic friction. Okay. For the static friction, what we know is that the two factors, the coefficients of the friction, mu s, and the normal force together can only determine the maximum possible static frictional force. They wouldn't determine the actual frictional force given in any situation. Okay, so mathematically, you can say Fs max, the maximum possible frictional force equals to mu Sn, or you write down it as an inequality. Fs is always smaller or equals to Fs mu Sn. Okay, so of course you can see the trouble comes from the fact that that's not equality. So in most cases, you cannot use this to calculate the frictional force. Okay, for static frictional force, it's an inequality. You only know the range of the possible frictional force. And then, if that's the case, how can we determine the frictional force? Okay. Please note that in this case, the static frictional force acts like some constraining force. So it can only be determined from the force analysis, or more precisely speaking, it can only be determined by solving the Newton's second law. Just like how can you calculate normal force? Okay, there is no way you can calculate it from the definition. You always calculate this kind of constraining forces, normal force or static friction, after you solve the Newton's second law, right? Okay. But for this one, usually it's not that difficult because you are, by definition, static friction happens whenever you cannot move the object. So the object is definitely in the equilibrium. It's not moving at all, right? So in the equilibrium, the Newton's second law effect is quite easy, right? The net force equals to ma, so that means net force equals to 0, right? And in this case, if you have some external pushing or pulling force, and then it has to cancel the frictional force exactly, static frictional force, and to make 0. Okay. So in this case, similarly speaking, the free static frictional force should exactly the same with the external pushing or pulling force. Okay. So static friction equals to external force. So that's just some simple analysis from the equilibrium condition. Okay, so that means if you apply some small force to the object, you cannot move it. Let's say you just apply 2 Newton forces, then the system will respond you to 2 Newton static frictional force. Okay? So the system is lazy. It will respond that amount of force to exact cancel your external force and wouldn't give any more. And then if you increase your external force to 10 Newton, then the system will respond you with 10 Newton frictional force. Exactly cancel your external portion. You couldn't move it, and then that's it. He wouldn't respond you with 11. Okay, you wouldn't waste any his effort. And this argument can go up to the external pushing force reach the maximum possible static frictional force. If the maximum possible static frictional force is only, let's say, 40 newtons, then the system cannot give more than 40 newtons. So in this case, if you still have a large forces, like say if you give 50 newton pushing, and the system can only give 40 newton static friction force, what happens? Then the object starts to move. So when you try to move anything, you have to give the force enough to overcome the maximum static friction. Okay. Question?
So is static friction always greater than kinetic friction?
Yes. So the point is that after you make this object moving, then suddenly becomes a kinetic friction. And kinetic friction is always smaller than the static friction. So then the frictional force becomes less. So that's kind of related to the experience that it's quite hard to move some static object. But once it's in motion, you can probably feel that you can use a smaller force to maintain the motion. Okay, you have this kind of experience. So for example, it's kind of like if for some system, the Fs max is like say 40 Newton, and the static kinetic friction is 30 Newton. So to make the object move, you need to apply at least 40 Newton. But after that, you only need to apply 30 Newton, at least 30 Newton to keep it moving. Okay. So that's a frictional force. And okay, so that's something complicated for the static frictional force. Okay, so when you determine static frictional force, you need to think about several factors together. You need first to consider if it reaches the maximum value, and if it reaches the maximum value, it becomes kinetic friction. If it's not, then it has to be determined from the equilibrium condition. Okay, so there is no simple way to calculate it. There is no just one equation. You need first to do some judgment before you do the calculation. And another thing more complicated the situation for the static friction is the direction. Okay, for the static friction, the direction of the force, frictional force, is along the contact surface opposite to the tendency of the motion when there is no frictional force. Okay, so both of them against the motion, but for the kinetic friction, you already have the motion, so it's relatively easier for you to judge which direction is opposite to the direction of motion. But for the static friction, you don't really have the motion, so you have to find out the tendency of the motion, the direction of the tendency of the motion, if you don't have the frictional force. And then the frictional force will kill this tendency. Okay. So basically speaking, in some simple situation, you know how to do it. If you try to push the object in this direction, okay? And of course, then you try to make it move to this direction. Even you don't really have the motion, you have the tendency to this direction. So in that case, the free static frictional force will be opposite to it. Okay. But sometimes it may be get complicated because you don't have real motion. So you have to think about it twice. Okay. Now let's look at one example. For the following configuration, assume all the surface are